Example 5, part D, we have an integral again. There is not a quotient rule for integrals, so you'll notice we brought the numerator up and gave it a negative exponent. That quantity, therefore, would be to the negative 1 power. This does become a product, but there's not a product rule either. So again, all these rewrites, I would hope again that this would conjure up in your mind that we have a quantity to a power here. And when we see that, we have hopefully grown accustomed to the idea that we'll replace that entire quantity with a single variable called u. This is a complicated, x, you're too complicated for me. I'm going to replace you with u. I'm going to run off with u. You're too complicated for me, x. So this new integral will be u to the negative 1 power, won't it? Yay! That's simpler, isn't it? dx. We always build everything off of that original substitution. We differentiate both sides with respect to x. This is a recording, isn't it? So this becomes 6x squared plus 9 minus 0. 6x squared plus 9. Clear fractions. Clear fractions. This is the same pattern we've seen multiple times here. And we have 6x squared plus 9 dx. And of course, we're going to get the dx. That was the whole purpose in differentiating both sides with respect to x. The question always becomes, what fell in our lap? Well, we got two terms, 6x squared plus 9, but we rather it be 4x squared plus 6. And it's not. So here's what I would tell people. We want to change that 6x squared into 4x squared. So we introduce a multiplier. I'm looking at these two terms, right? We want to change this into this. So how about we cancel the 6, replace it with a 4, which by the way is 2/3. So the hope will be that 2/3 will be those are the same number, right? But I like to put 4/6. I learned a long time ago when I put it that way, people can see, oh, the 6 cancels and gets changed into a 4, cool. All right, so if this is gonna work, and there's no assurance at this point that it's gonna work, because when we distribute that 4/6 to that first term, indeed it gives us the 4x squared that's in the original integral. I guess I don't need the parentheses anymore. That's going to be 4x squared. But here's the thing. Actually, I do need the parentheses. You can always fix that first term to match that term up there. But this is where you cross your fingers and you say, man, I sure hope that that same number distributed to the 9 will become the other term. Please, 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 please. Does it work? 4/6 times 9/1, arithmetic, that would be 36/6. What is that when you multiply that number by that 9 in the parentheses? It's 6! Wow! That was lucky, wasn't it? Okay, look. This question was contrived. We're in Calc 1. This is going to work. It needs to be said that if that would have been any other number in the world other than 6, any other number in the world, 7, 32, 19, whatever, this term would have worked, but the other one would not have. Thank heaven, that was a 6. If it was any other number in the world, this whole process would have been for naught. What do you do if that was a different number? Calc 2. You learn other techniques of integration. Okay? So, thank heaven we're in Calc 1. All right? So, that stuff there is 2/3 du. Wow! That sure was nice. I'm sure glad I'm in Calc 1 where it works. Again, I'll say it, if it was a different number than 6, substitution doesn't work. You learn other techniques. Okay, moving on here. Oh, this is cool. Oh, we just do the power rule, right? Let's try the power rule. Let's see. N plus 1 over n plus 1. What? That led to division by 0. What? What is going on there? Let's see. Oh no, my mouse is stuck. Okay, here we go. All right. So here's what we need to recognize on this. The power rule didn't work there, did it? Because that led to division by 0, didn't it? Oh my gosh. What? I thought the power rule always worked. Well, okay. U to the negative 1 is 1 over u, isn't it? Okay, and again, I hope we made our point that the power rule didn't work there, did it? So here's what I would just throw out to you. That's a 1 over situation, isn't it? And we want to integrate a 1 over. Its derivative would be natural log. Oh yeah. Okay, so that's the other scenario here. If your power is negative 1, we hopefully made the point that that power rule would not have worked on that particular situation. And so when we integrate a 1 over situation, which is negative 1 power, see, I'll take you back to the day when we did the power rule, n plus 1, n plus 1. But didn't we say that if the n is negative 1, then you're going to get division by 0? And that's the exception to the power rule. All right, so when that power is negative 1, doesn't work. Okay, so that's the exception to the power rule. So we got to remember that negative 1 power is 1 over, and 1 over is the derivative of natural log. Therefore, this integral will be natural log. Now there's absolute value here. That's because natural logarithms can only be applied to positive values. And so to ensure that that comes out positive, we'll put an absolute value around it. So that's just part of that definition. So just remember that when you see that negative 1 power, power rule doesn't work. You're going to get division by 0. 1 over, got it. So we come back over here and we substitute back, and we have 2/3 natural log absolute value of the quantity that you replaced plus c answer. Aha! Got it. Okay, so that's our other rule. If we want to integrate a 1 over, which is also x negative 1 power, we've got to remember that the power rule isn't going to work, and we use this new idea. So that leaves us there. Let's come back. We'll do a couple more on this slide. I think we have about 6 more of these to enjoy.